Hello and welcome to the Plastek Academy. We are pleased to bring you today's webinar featuring hot runner basics and technology overview presented by MoldMasters. My name is Doug Preshak, Vice President of Global Tooling and Engineering at the Plastek Group. Plastek has been working with MoldMasters for over 20 years and we've enjoyed a mutually beneficial relationship during that time. While there are several excellent hot runner manufacturers in today's market, MoldMasters is among the best. They deliver exceptional hot runner solutions which we have come to rely on, and they are always there to support their product. That is why they are always on our list of hot runner suppliers for new projects. Expertise, professional service, and overall value is something you can rely on when working with MoldMasters. To our viewers, I thank you for joining us today. With the Plastek Academy's mission to provide you with a virtual experience to be educated on best practices for success. I'd like to now introduce you to our guest speaker, Neil Dewar, Director of Technology at MoldMasters.
Well, good morning, everybody, and thank you for joining us, and thank you to Plastek for this opportunity to present today. My name is Neil Dewar, and I hope you enjoy our presentation today. So first of all, MoldMasters. MoldMasters has recently been acquired by Hillenbrand. Hillenbrand is an organization that has several different companies in different diverse industries. And MoldMasters previously had been under part of Millicron. So Hillenbrand bought out Millicron. And our Hillenbrand's approach is to promote the MoldMasters name and the MoldMasters brand and allow each company to operate individually. So the MoldMasters brand is proudly back. So a little bit about MoldMasters and what we do. We design and manufacture hot runner systems. That's our core principal business. Associated with the hot runner systems are, of course, temperature controllers. And we also provide auxiliary injection units, which we call an EMulti. MoldMasters global presence. We were founded over 50 years ago, 1963 to be exact. We do business in approximately 100 countries globally. We have over 2,000 employees. On a daily basis, we manufacture over 500 nozzles. MoldMasters has always been very strong in terms of our intellectual property and our technology and developing new technologies. And today we have over 900 patents associated with hot runner systems and hot runner technology. Over the years, we've done many applications. So we have 150,000 different molding applications. Globally, we have 4 manufacturing locations. They're located in Canada, in China, in Germany, and in the UK. Globally, we have 15 service centers with 140 global field service technicians to support our customers. So what is a hot runner system? So the hot runner technology was introduced over 50 years ago and really revolutionized the whole injection molding process. So a hot runner system conveys molten plastic from the machine nozzle and has a system of melt channels that are thermally controlled by electrical heaters and thermocouples to deliver the melt, the plastic, to various different cavities. Today's molds, we can have 1 cavity or 192 nozzles, depending on the parts being manufactured, their size, materials, etc. So this image here just shows you a very simple 2-drop or 2-cavity, 2-nozzle hot runner system. Some of the components that we can see are the inlet pointing down to the floor here. And then we have 2 nozzles that will feed the plastic into the cavities. The plastic comes in and goes through a manifold and then enters into the nozzles to feed the cavities. So the hot runner system is going to be integrated into the mold, and the hot runner system is customized to match that mold design. And then the mold with the hot runner system is installed into the injection molding machine. Along with the hot runner system, there will be a controller, a temperature controller, and that controller may also include some auxiliary control as well. So the hot runners versus cold runners. So hot runners came into being. MoldMasters, as we say, were founded over 50 years ago. The oil crisis of the 1970s really promoted hot runner systems. People were no longer, they were being more careful about the energy they were using. They were being more careful with the use of petrochemically derived products so that they weren't disposing plastics as easily. And some of the benefits that they were able to achieve out of hot runner systems were faster cycle times, less waste. So here you can see a cold runner, and this cold runner has to be cut away from the molded parts. This plastic may, in some applications, be reprocessed. In other applications, it may be thrown out in the past. So the hot runner system will eliminate this cold runner and automatically provide parts that are detached from, there's no cold runner attached to them. So it's a degree of automation being built into the mold. Consumes less energy, requires less capital equipment. You don't need regrind. Regrind is always a variable in your process if you're using it. If you're going to eliminate that, then you have a more robust process. Highly automated, a degree of automation, and improves part quality. 100% virgin material being used, better process control. Today, MoldMasters serves a variety of different industries. So up in the top here, we're showing the different industries that we serve, providing consumer goods, electronics, medical, personal care, technical components, caps, closures, packaging, white goods, and automotive. To serve each of those, we have a variety of products. I'm not going to go down through the list, but these consist of different hot runner systems that are specifically geared towards certain applications and certain projects. So we can help to select the most appropriate hot runner product based on the application. We have advanced gating methods, including our AccuValve and others. A valve gate will have a valve pin that needs to be actuated to open and close the gate. So we have mechanisms to control that, to help to manage that process. We mentioned earlier temperature controllers. So we have a variety of temperature controllers. We'll explain a few of those today. Depending on, obviously, the number of zones, the size of the mold, but there are other features as well that can be included into the temperature controller. We have systems to help with the process. Our max controller is using servo motors that may be a feature in the hot runner system, but also a feature of the mold may include servo motors to actuate features within the mold, and we can help control that. We have other specialty equipment. I mentioned the EMulti, our injection unit, and we also have a co-injection process and product. So some of our core technologies, our IFlow Manifold technology is a technique that we use to manufacture manifolds. Our heater brazing is a core product or a core feature of MoldMasters hot runner systems. And then we have advanced capabilities with, for those different types of applications, high cavitation, tight pitch where nozzles are very closely positioned, stack molds, multi-material, a whole range of more advanced technologies that are using hot runner systems. The core technology is the Brazer Heating technology. So when we build a hot runner system or a nozzle, that heater is being brazed into the nozzle. So what that does is it means that several things. One is that when heat is generated in that heater element, it's immediately being transferred into the thing it's trying to heat up. It's metallurgically fused to the nozzle. It's a part of it. When we put a heater onto a nozzle, every nozzle that we make is going to have the same heater in exactly the same position, which gives us consistency of performance from drop to drop. By brazing that heater in there and ensuring that heater is being drawn away, or heat is being drawn away from that heater, what that does is it extends the life of the heater. So it's very unusual for a MoldMasters nozzle to burn out. Not impossible, but very unusual. A much lower incidence than conventional heaters that are not brazed into position. Our IFlow Manifold is a MoldMasters technology that has been around for over 30 years. The concept is that we take two pieces of steel and we mill the pattern that we want the plastic to flow through. We mill it into the surfaces on the two faces of that manifold. And then we braze them together, again, metallurgically fusing those two pieces together, very accurately aligned. So we can put in different runner geometry. We can also select the sizes of the runners and change them at different locations as we wish. We're not limited by a gun drill drilling in a straight line. So this gives us tremendous flexibility with many benefits in processing. Again, those manifolds are going to have heaters brazed into them so that, again, you have long life and flexibility from a design perspective, that we can position those heaters where we need to position them in order to achieve the optimum thermal profile within our manifolds. The IFlow manifold, also some of the features of it, we can put in different levels. So we have milled features where we mill the runner, but we can also gun drill some channels into that manifold as well. So we have different levels. This manifold that you see here actually has two different levels of runner channels built in. What that does is it reduces the stack height, not just the stack height of the manifold, but obviously the stack height, the amount of steel that has to go into the mold, can be made more efficiently. You don't need as much steel to build your mold. You can fit it into a smaller machine, reducing the overall stack height of the mold. This manifold is also designed with holes in it. The idea of these holes, the function of these holes, is to ensure that we have a robust and strong mold. We will have steel going through there. It'll be designed with steel that is part of the hot half, part of the mold, because that hot half has to support your cavity plate. So this flexibility in design of the manifold leads to a more robust hot half and a more robust mold overall. So some of the gating methods, I kind of mentioned this a little bit, open gate versus valve gate. So the valve gate is kind of obvious in that mechanically you move a valve pin and you now can flow plastic through the gate. Non-valve gating relies on cooling to close the gate. And there are different designs according to the type of gate quality, the type of material being molded, and the gate quality that you want at the end of it is a major factor. So some of the gating methods that we would have with non-valve gating would be a torpedo gate. Here we see what we call an E-type torpedo. Again, there are different options depending on the desired gate appearance and the material being molded. Valve gating, we have, again, different options based on part size, based on material being molded, and the quality of gate that is required. Our premium gating method, our premium valve gate, we call AccuValve. So AccuValve features, again, different types of gating methods with different benefits and suitable for different applications. Our most common is our AccuValve MX. The AccuValve CX is designed for excellent color change. And our AccuValve GX features a component that actually goes through into the cavity and forms part of the cavity surface. So in order to achieve highest quality gates, it requires a fine tolerance between the valve pin and the gate. With these gating methods, the mold maker needs to achieve that tolerance on the gate finish. With the AccuValve GX, MoldMasters takes care of not just the valve pin, but also the finish in the interfacing component. So right down into the cavity steel. So it is simplified maintenance, easily replaceable gate steel, and easy integration into the mold. Bioresin, we've heard a lot about bioresin. MoldMasters has been making applications for many years, using various different types of material that is more environmentally friendly. So bioresins have had a lot of focus in recent years, and MoldMasters technology lends itself to these types of applications. Some of these materials are more thermally sensitive. They have a narrower process window, and we have systems that are more suited to these types of materials. So we have a wide experience on a wide variety of bioresins. That means degradable materials, compostable materials, and PCR, post-consumer regrind or recycled materials, which are reducing the carbon footprint of products and attractive to many applications. Stack molds. So this is one of the more advanced technologies. So over 35 years, we've been supplying systems for stack molds and hot halves for stack molds. One of the questions about a stack mold is how do you get the melt into the center section of the mold? So a stack mold is going to have two molding faces. So within the mold, when the mold opens, you have two parting lines. This means that the hot runner system is actually in the center of the mold and moves away. The center section is moving as the mold opens. So we have different techniques to get the plastic from the machine nozzle into the hot runner system. The most common is the sprue bar, which we show here. We also have another feature, which is another type of design, which we call a valve-to-valve. And what the valve-to-valve does is it eliminates this sprue bar. So when the mold opens, you don't have an obstruction going across the first parting line. And what you have instead are actually two valve gates that feed into each other. So you open up, you shut off between each face of the valves, and you pass plastic across the parting line, and then close the gates, one closing into the other. So when the mold opens, you have a fully clear opening. That type of technology will be used if you need a robot to come in, and the sprue bar would be an obstruction that would get in the way of that. Or if you want parts to free fall and you don't want them bouncing off a sprue bar, we may use a valve-to-valve mechanism in that instance. Multi-material capability. We make systems that use different materials. So injection molding one material onto one face, and then a rotation may occur within the mold, or a mechanism may open up a different cavity in the mold. So you make a part that has two different materials, one molded on top of the other. And doing that in a stack mold makes it even more complex. Another advanced feature is side gating. So we have different options for side gating. One is our melt cube EVO. So here we see a melt cube, and on the side of it we can see the feed points that are going to feed into the cavities. So the cavities are going to be positioned so that the mold can open and close, and the part is being fed in the side of the part. And here we have another 4 cavities over on the other side here. So you're getting multiple cavities. The cavities are aligned in rows for simplicity and for getting more density into the mold, more cavities for a given mold space. Our melt cube is similar, except now the tip is angled at a slight angle. So if you don't have an exact vertical wall, you have another feature that you want to mold a gate into, we can accommodate that. What you don't see here are all the runners that are built in here so that we have a balanced flow path to each one of these gates. And if you wanted to see more detail on this product, you can take a look at YouTube, and if you just put in MoldMasters and do a search for MoldMasters, you'll see a variety of videos that will go into this type of technology in more detail. The third side gating that we show here is the melt disc. And on the melt disc, the cavities are arranged in a circular pattern. And then we make this disc that feeds into the side of each of those gates. So these are what we call more advanced technologies. We would be very pleased to review any applications that obviously some thought needs to go into assessing the application and verifying that it's valid and suitable for this type of gating method. And we'd be happy to review any applications where that might be considered. Specialized dual gate design. So we have a special melt cube that allows us to gate into a part on both sides. So here we can see a part, and we're gating in from on two sides. The reason that we want to do that is to reduce the possibility of core deflection. So if we're making a part and we gate it into one side, the plastic has to flow around the core pin. And as it starts to flow up along the core, it's going up faster on one side than it is on the other. That's a problem if this core pin is not located at the open end. If you have an open end in the part, parts like blood vials, you can't shut off on the top of the core pin. So if your plastic is moving up on one side, you may cause that core pin to deflect and get pushed over. If you were doing it with a cold runner, you'd make the cold runner come in and do it come into the cavity on both sides. So how do you do that with a hot runner system? So what we do is we come in and we feed from two different sides. And just let me go back a slide. So here, the secret in how we do it is we have two inlets into each of these melt cubes. So one inlet would feed in, we're looking at it from the parting line side here. But on the other side, plastic is being fed in this location and is being distributed to give uniform flow to each of these four cavities. We will have another inlet here that would feed into these four cavities. So if we had 8 cavities, here we just show 4, but if we had another 4 cavities here, if we had 8 cavities, we would use 3 of these melt cubes. And at the end of the row where we're not going to mold a part here, we do not feed plastic into this location. The result is that we have 3, for 8 cavities, we would use 3 of these melt cubes and they would be identical. And we would feed them in 4 different places. So each of the cavities are being fed in from both sides. They are being fed in uniformly. These melt cubes are all identical, just that these guys are not being used to mold plastic. They have the same components in them. They're shutting off here. So we have the same thermal condition, the same thermal environment. That gives us identical balance and solves the problem of how do we feed in from both sides. That gives us excellent balance, excellent control of filling, and that translates into straightness on parts such as pipettes, where straightness is a critical concern. At the beginning of the introduction, we saw a reference to a MoldMasters hot runner system that Plastek use. This is what we call a tit edge system. And here we see 2 gates. And here's how this gating method actually operates. We're going to gate into the side of the part that we see here. On the left-hand side, we can see an example of the gate witness. So there is a witness mark where this gate is positioned, feeding into the side of the part. Here we generate a cold slug. As the mold opens, it takes the part away, it degates, cuts this off with a clean gate appearance. And then on injection molding the next cycle, we push in that cold slug, we remelt it, and we allow the part to fill. So we have a fully automatic degating process, good gate quality, and no moving parts other than the mold, of course. We don't have any shut-off mechanism in here. This is all controlled thermally. This gives us excellent color change, excellent balance, and that is the gating method being used. And the system that Doug showed has 36 nozzles, so it's a 72 cavity mold. Valve gates require some mechanism in order to actuate the valve gate. That may be hydraulic, maybe traditionally has been hydraulic or pneumatic. So we have mechanisms or control systems to control the actuation of the valve pin. This is a sequential valve controller. So sequential gating will be used where we want to control, we're not going to open all the gates at the same time and fill simultaneously. If I have a large part with multiple gates, I open all those gates and start filling. The flow front between two gates is going to meet in the middle, and you're going to see a witness mark on the molded part. What sequential valve gating does is it allows us to control the opening time of the opening position of the pin. So you don't open them all at the same time. So if you wanted to move the weld line or knit line in one direction, you open up one gate first, and then slightly later, you open up the second gate. So you can control the position of that knit line between the two gates. If you have a large part and you want to avoid witness lines between gates, you open one gate and take the flow front past the second gate. And after it is past the second gate, you open up that second gate and now push that flow front further along, perhaps to another gate. So sequential valve gating can help to eliminate witness lines or knit lines, or at least help you to position them to where you want them, to less objectionable positions. EDrive is an electric synchro plate system. So all of the valve pins are being put onto a plate. And here we have a servo motor that is going to actuate, drive this belt. Here we have a couple of idler pulleys. Here we have ball screws that are going to move a plate up and down. Here's a little image of the plate. We'll show you more on that in a moment. Servo electric valves. So we have a valve gate that instead of a hydraulic or a pneumatic unit can use a servo motor to drive the valve pin. So this tends to be used on lower cavity and big systems. Again, this can be combined with the sequential mechanism to control the timing of the valve gates. Servo control gives us control not just of the time when we're going to open the gate, but also the position of the pin as the pin opens. We can control its position, and that can influence the gate quality and appearance of the gate. We can also control the speed that the pin is closing, for example. And again, this can have an influence on the quality of the molded parts. So the EDrive, this is an example showing quite a large mold. It also features our manifold technology. So this mold is an 80 cavity mold. So that's a little bit unusual. Here we have a servo motor that drives this belt around these ball screws and idler pulleys, so that we have a plate in there that is going to move up and down to open and close the gates. So here we see this plate. So we can position the pins nice and close together on this plate. So our cavities we're getting more cavities out of the mold. But you're not going to be able to get individual actuators to move these pins. So we put them onto this plate. And here we have, this is half of the mold, so we have 40 of these pins on this mold. And actually these slots allow you to access those pins within the mold. So if you damage a pin, you don't have to take apart the whole mold. You can gain access to it from the back. So this plate, this actuation gives us very uniform movement of all the pins all together, which helps with part fill and balance. So what happens if we damage a cavity? I've got an 80 cavity mold, it's a big mold, and I've got a cavity that is dimensionally incorrect, or I've damaged the cavity. Can I shut off, or how do I shut off one cavity? So this is a mechanism that we refer to as our MagPin technology. So the servo plate is contains this mechanism with the valve pins. So in order to shut off a cavity, what we do is we stop molding, we drop the temperature in the cavity we want to shut off. As the temperature of the material in the nozzle drops, the plastic solidifies and holds onto that valve pin. Now, if we actuate the valve pin, the plate moves, but here we have a magnet feature that lets go of this valve pin holder. So this plate can still move up and down, but this pin is not going to move because we've dropped the temperature on that nozzle. That is the MagPin technology. When I want to get this pin to move again, I just turn back on that nozzle, and now this magnet will pull the pin up and down. And all the pins each have their own individual magnet. So any individual cavity can be deactivated just by dropping the temperature on that drop location. SEVG Plus, this is our Servo Electric valve gate. So this is a servo-driven system, giving us absolute precise control over individual gates. Allows us to individually adjust each valve pin, so we can change our stroke, we can change our speed. In a family mold, you may require different features on different parts, different timing and of opening of different pins. So this gives you tremendous flexibility across the mold. You can adjust the valve pin positions in increments of 0.01 millimeters and make adjustments on the fly with this. The screen is easy to use and very user-friendly. The servo motors have traditionally been a challenge because of their size. This is something that we have been working on, and MoldMasters has introduced a new servo motor that is 40% smaller stack height than conventional servo motors. The footprint, the size of it, otherwise is about the same size as a standard hydraulic cylinder, so just over 4 inches square. But the stack height has been reduced by 48% and still incorporates water cooling channels that are necessary to maintain the temperature of the servo motor. Temperature controllers. MoldMasters offers a range of temperature controllers depending on the size of your molds, the number of zones that you're going to need. We're excited to introduce the TC Connect. TC Connect eliminates thermocouple cables. If you look at a high cavity mold and look at the size of the cables that are going up to take power up to that hot runner system and to take all the thermocouple leads back down to the temperature controller, we've eliminated the thermocouple cables. You don't need them anymore. Instead, you have just a single wire like a LAN wire. So the wiring goes into the box on top of the mold, and this simple cable talks to the temperature controller and gives you the same control as you would have conventionally. Some process control features that we offer: water flow monitoring. Water flow is quite often overlooked in processing. We can outfit your mold so that we monitor the temperature and flow rate of each circuit. Max controller, if we have a valve gate that is using servo motors, we have a controller obviously for that, but we can also extend control to look after mold features. So a servo motor may be used as part of the mold design for other things other than the hot runner system. Many customers were building two-shot molds, so squirt one plastic and then move something in the mold and put another shot over it. Toothbrushes are a classic example. To facilitate that, we developed the EMulti, which is a bolt-on injection unit. So you have a conventional injection molding machine. You can then get an EMulti system, variety of different sizes according to the shot size that you need, and you mount it where you need it. You can put it up on top of the mold, as we show here, going vertically into the mold. You can have it piggyback over the existing injection unit. You can have it on the non-operator side or at an angle. You get creative as to how they're mounted. This means that you can convert a single shot machine to a two-shot machine. And when that project is finished, you can unbolt it and put it onto a different machine. So tremendous flexibility. Fusion G2, this is a different design of hot runner system. This is intended for larger parts, very popular in the automotive industry. And what you see there is what you get. It's pre-wired, all the electrical things done. What's different about it is that the nozzles screw into the manifold. So the nozzles are mounted on the manifold, and so can be dropped in as a complete assembly. Co-injection is slightly different from bi-injection, or multi-material molding. Co-injection is where you inject two materials through the same gate at the same time. And what that does is it puts a layer in between, a core layer. That core layer may be used to prevent oxygen going through, permeability going through a package, and extending shelf life of a product. Or it may be used on thicker parts. You want to get some post-consumer material into the center core to reduce the cost of your material. And you have nice white virgin material on the outside of the part. So that's our co-injection system as well. And that's a quick overview of our MoldMasters technology. I'll pass it back to Nicole.
Thanks, Neil. Hi, everyone. I just want to join you today to thank Neil for our presentation, and again to give a thanks to MoldMasters for partnering with us and giving us the opportunity to hear all this wonderful news. So I want to join you today. My name is Nicole Freeman, organizer for the Plastek Academy and corporate marketing manager for the Plastek Group. Next on our agenda, I will be assisting with our Q&A session. With all of the great talent that we have in the industry and quality technology, we know that this technology continues to evolve on a daily basis to meet our numerous number of needs in our operations. So with that said, in our presentation that was given today, I encourage you to identify the questions that you have about hot runner systems and the technology overview and share them with us during this time today. For those of you who are using GoToWebinar for the first time with us, you'll see on the screen the blue arrow points out where you can find the text box where you can type in your question and send that in to us. We do encourage you to ask more than one question, and we'll get to as many as we can today, but please submit one question at a time so that we can review those. As you guys are submitting those, I have one more housekeeping item, and I just want to give the reminder for those of you who are looking to use this information outside of today's webinar and pass it along to others in your organization. We have uploaded 3 handout PDFs, which you can find in the handout section of your dashboard. When you click on those, they will open another window so that you won't lose them upon your exit of the webinar, and then you can save or print them at a later time. Okay. So I will just give a few moments more to have you guys enter your questions. We'll have Neil join us again, and then Quite possibly, depending on your questions, we actually have an additional guest with us today, Jim Buman with Millicron, who is a well-known face around Plastek here. So we may hear from him as well, depending on your questions today. Okay. All right, so one question that we have, we'll get started. Looks like we have just a couple minutes left. So our first question, what are the benefits of your two-piece brazed manifold technology?
Thank you, Nicole. The two-piece brazing technology gives us a lot of flexibility from the design point of view. So we use two-piece brazing technology, and we also use gun drilling. So we use both of those technologies together. And the advantage of having the two-piece brazing is that we're not limited to straight lines. We can put in curves. This gives us the opportunity to achieve natural balance for some layouts that are unusual. One of the examples we saw had a 10 cavities in a line, 10 cavities in a row. That is something you're not going to be able to do with traditional gun drilling. The two-piece brazing also allows us to put the runners out of the way of mechanical functions within the mold design, so that we can make a more robust hot half, and that has implications in terms of more robust mold, clamp force, mold wear, and all of those things as well. So there's some of the benefits of our brazing technology.
Okay, great. Thank you. Our next question is, do you have anything to add about recycled plastics processing with MoldMasters hot runners? What are the challenges or specialties?
A very topical question. Thank you. Yes, we have a number of systems that are processing recycled plastics. There are a number of companies that are offering different grades of post-consumer regrind. We have found that many of these materials are direct replacements for conventional or virgin material. They may tend to have a wider variability on viscosity, for example. If you look at the specifications of the material being offered by the supplier, they may say that it has a melt index between 10 and 15, for example, which is a broader range than you might find with a virgin material. Other than that, we have had good success with recycled materials.
All right, our next question, we have a couple more. Let's see. Balance is great, but most molders will run a mold with 5 to 8% cavities shut off to keep the mold in production. So how critical is mold balance?
The answer is it depends. Yeah, the real world means that you may have to run with a less than ideal condition. And in certain applications, that may be acceptable, and you may be able to make an acceptable parts. Balance has become more and more important within the industry. If you're making parts and you don't have consistent balance, if you're making a screw closure, for example, the filling of those parts is going to be different. They're going to pack out differently, and some parts are going to require more torque in order to unscrew the core. If you have more torque on some cavities compared to others, some cavities are going to see more mold wear than others, for example. Some cavities are going to require more clamp tonnage than others, and that costs in terms of wear and machine size, for example. So yeah, you can make compromises, and sometimes you have to make compromises in terms of balance to get product out the door, but not all applications are going to accept that. So yes, balance, again, it depends on the application, and we pay a lot of attention to ensure that we're getting the optimum balance from our systems as they go out the door.
Okay, great. Can you briefly comment for an answer? The question is, do you offer co-injection manifolds for EVOH for barrier properties for food and beverage?
The answer is yes, we do. Yeah, we do a wide variety of EVOH and nylon and other barrier materials. We have a very thin layer in the center of the product that gives you the barrier properties, and we have excellent control on the leading edge of that barrier. So you're not putting in more than you need to, and you're not putting it where you don't need it, so that you're optimizing your process, and there are economic implications to that as well. So that is a well-proven technology.
Great. Okay, we'll do one more question today, and that would be, with co-injection, how you separate and control the flow of the two materials passing the gate of the nozzle and filling the part.
So there are different designs out there and different techniques to do that. So the flow is controlled. We have two channels. Just to briefly describe it to you, we have two channels that are within the nozzle and two channels feeding into that gate. We have a valve pin that we can position to restrict the flow of one channel, and also then we can change which channel is flowing and how much volume is going through each channel. So we can go from solid material A to a thin layer, well, material B going in there, to then having 100% of material B. We have full control of each of those materials, and it's controlled partially through the design of the nozzle and components within the nozzle, and by valve pin control.
Great. Well, I'm glad that we could have the opportunity to answer a few of your questions today that came in from our audience. Thank you for that, Neil. And again, thank you to MoldMasters. Certainly, we've got the contact information for both Plastek and MoldMasters here in the presentation, so feel free to reach out to us, and we will review any questions that we did not get to today. Okay. I'd like to then complete the webinar for this morning, and again, thank everybody for your participation. As we close, we do have one request that we can ask of our audience. And for our return viewers, you know what's coming. And for our first timers, here's your chance to participate with us once again. So as you exit the webinar, you will see a prompt to participate in a very short survey. We have just 4 questions to ask you today. And you can either choose to do that right after you exit, or I know that we are conscious of time, so we've accommodated that with a second opportunity. You should receive a follow-up email within the hour after this webinar, and at the bottom of that email, we have included the survey link. So we do encourage and appreciate any feedback that you can provide to our team today. Okay. And then lastly, from us here at Plastek, for those of you who have been following us, you know that this is our 4th webinar that we've completed in our new series. And we've got a great lineup for you already identified in advance. So while we encourage you to participate in all of our events and upcoming through September 2021, we wanted to make sure that this continues to be valuable to you. And therefore, with that lineup in advance, you can create your own mini series and attend the webinars that best fit your needs. So be sure to check out those topics at plastekgroup.com. And until next time, happy holidays.